Hello and welcome to everyone. In this video, we will discuss the types of body in a fluid flow. There are two types of body in a fluid flow. First one is the streamlined body and next one is the blunt body. Then what is meant by a streamlined body? A streamlined body is a shape that lowers the friction between fluid like water and air and object moving through that fluid. When an body which is placed parallel to the streamlines is called as the streamlined body, which lowers the friction between the fluid like water and air and which the object is moving through that fluid, that means which is moving through the water or air. And in a blunt bodies, a body is the one that as a result of its shape has separated flow over the substantial part of its surface. When a body is placed perpendicular to the flow, means its axis is perpendicular to the flow, which creates a wake formation zone or eddies formation zone, that means boundary separation of boundaries take place. This type of body is called as the blunt bodies. In this, pressure and form drag. What is meant by pressure and form drag? First one is the shear or skin friction drag. The part of the drag that is due to directly to wall shear stress tau W is called skin friction drag. The formula for the skin friction drag, Fd at friction, which is equal to 1/2 into Cd, that is coefficient of drag friction, into rho v square A. Fd is the drag force due to friction and Cd is the coefficient of drag due to friction, into rho is the density of the flow or fluid, into v square is the free stream velocity and A is the area of the body. Next one is the pressure or a form drag. The part of a drag that is directly due to pressure P is called as the pressure or form drag, which is denoted by Fd. Here it should be a pressure, not a friction. Fd pressure, which is equal to 1/2 into Cd pressure into rho v square A. Please note that here it should be replaced by a pressure. This is not a friction. Okay, this is the plate which is a blunt body, which is its axis is perpendicular to the direction of the flow. The left side of the body causes a high pressure region and low side of the body has a low pressure region. This shows the wake formation or eddies formation in the low pressure region. That means boundaries are separated in this region. Dependence of a shear drag. The shear drag depends on the following point. First one, on the orientation of a body. Next, the magnitude of a wall shear stress. Next, viscosity of the fluid. Then Reynolds number of the flow. Then surface area, and last one, the surface roughness under the turbulent condition. Now the dependence of a pressure drag. Pressure drag becomes significant only when fluid velocity is very high, and it also depends upon the layer separation, where separation of the flow take place. And last one is the orientation of the body. Thank you.